Let's take a look at how we could evaluate this limit. The limit as x approaches 5 of x squared minus 25 over x minus 5. And we're going to do it by evaluating values of x into that function and seeing what y would be. And what we're doing is looking at a table to get the answer to this limit. So since x is approaching 5, oops, forgot to turn off my eraser. Since x is approaching 5, I went ahead and drew it left to right so that you could see you want x values to come from the left toward 5, and you also want the x values to come from the right toward 5. So here's 5 in the middle. Okay? Now, if I plug 5 into this equation, I get it to be undefined. So right there in the middle at x equals 5, we know our function's undefined. But remember, we're interested in what what y is approaching as x approaches 5. So these are the values I pick. You don't want to get too far away from 5 because different things with the function could be going on. You've got to get really close to 5. So closest I got was 4.9999, and then I just moved to the left from there. So 4.999, 4.99, and 4.9. Okay? And then going to the right, really close to 5 would be 5.0001. And then getting a little farther away, but still pretty close, 5.001, 5.01, and 5.1. These are the x values that you'll enter in your table, and I also wrote them vertically because that's probably how you're used to seeing them if you're going to put them in your calculator. So let's go and look in Desmos and see what happens and what we get. Okay, so you could use your calculator or Desmos, but for showing students, I like to go ahead and use Desmos because it shows up so nicely. But here I've entered our function into the first line for graphing, and you notice you get a line, and this is a line with a hole in it. So let's see if I can just bring it down a little to where x is 5. Use my pointer. Here's x is 5. It's undefined right here. So I'm going to try to click right there and see. See how it's saying 5 undefined? Okay. I'm just clicking and holding, and Desmos will show you the point there. Okay, so we do in fact have a hole there, but remember we want to know what the limit is. Now we can tell by looking at the graph. I'll move this down just a little bit for you. We can tell by looking at the graph that the limit as x approaches 5 is going to be 10 because that's the corresponding y value right here. The values are getting closer and closer to 10, both sides. But we want to see how this looks in a table of values. What if in a problem you were asked to use a table and you had to justify your answers by showing the table? So what you can do if you're using Desmos is click the gear and select table, convert to table, and now you can enter values in there. And you know, there's already going to be values there, but you can delete them. And just enter the ones you want. So I'm going to do the same thing we did when we were setting up our table. So farthest away from 5 is 4.9, and I usually put the ones at the top, I put the ones at the top like they're to the right because top to me is positive and going below would be negative. So anyway, so the farthest away on the right side above would be 5.1, and then 5.01, and then 5.001. So I'm just entering the x values as I get closer and closer. And then I happen to just say 5.1230 zeros and 1. Okay? And then we can put a 5 here just to kind of show that that's where we're headed. I didn't mean to put a negative. Let me take that away. Okay, notice it's undefined as we knew it would be. Okay, now we're coming from the left. So closest to 5 from the left would be 4.9999, and then 4.999, and 4.99. Now the reason you use different values and don't just get super close is you want to see that they're actually approaching that value, getting closer and closer and closer. So 4.9 would be the last one I would have to do. Okay, so look at this table. You can see that as x approaches from the left to 5, then the y values are going from 9.9 to 9.99, 9.999, and so forth, very close to 5. Same thing is happening coming in from the right. Farther away, it's 10.1, but then it gets 10.01, 10.001, and so forth. So you can see on both sides, coming from the left and the right, the y values are getting closer and closer to 10. And we ask you to do this so that you get a really good understanding of what we mean by the y values approaching a certain value. Okay? And it helps you to see it visually and understand the problem more fully. So from our Desmos graph, we can see that the limit as x approaches 5 of this expression is 10. Now, we looked at the graph and we saw there was a hole there and that the limit should equal 10, so the graph was great to look at also. And algebraically, let's just go ahead and put it all together. So let's use algebra here. Algebraically, we would do this. The limit as x approaches 5, and I'm going to factor the numerator. And the denominator is already okay. It's already factored. Okay. Now, how do I know I need to factor? Well, if I put a 5 in right now, I get 0 over 0. Well, when you get 0 over 0 as an answer, which is called the indeterminate form, you can't calculate the limit, but when it's 0 over 0, it's a good sign that you can actually simplify and try again. So the way we would simplify this time is to factor the numerator and the denominator, if we had to. And notice the x minus 5's cancel, and that's what tells me that there's a hole at x equals 5, as we saw in the graph, and it's actually at the ordered pair 5, 10. But now let's plug 5 into this expression now that we've simplified, and we get the limit's going to equal 5 plus 5, which is 10. So you can see we got the same answer from a table, from algebraic methods, and from the graph. Okay? So it ties it all together.